This is Chapter 8, Section 3. This is geometry. This is Mrs. Norris, and we're going to talk about right triangles again. We're going to use SOHCAHTOA or trig relationships, and we're going to be able to fill in all the rest of the missing information about the triangle. Okay? So we're going to learn inverse trig this time, and we're going to continue to assess our understanding of the sine, cosine, and tangent trig relationships. So what you see here is a printed example. It's giving you the fact that the sine of angle A is 0.8, and they want you to figure out, is angle 1 A, question mark, or is angle 2 A? Which one of these two is angle A? So what we're going to do is we're going to use the fact for angle 1. If angle 1 was your reference angle, what would be the opposite? Obviously 6 would be the opposite. So you're going to put opposite, or 6, over the hypotenuse, and in this picture the hypotenuse is clearly 10. So what do we get when we do 6 divided by 10? We get 0.6. Obviously it's not angle 1. So angle 2 also has a sine, opposite over hypotenuse. Let's go back to our picture. If we're looking at angle 2, which one's opposite? Which side is opposite? Obviously 8, so we fill in the 8. Which one's the hypotenuse? 10, we get 0.8. Therefore, angle 2 is obviously angle A. Now, what we're going to do next is we're going to fill in some symbols. This is called the inverse of sine. Sine is actually spelled S-I-N-E. The inverse of sine, it's found on your calculator. If you have your calculator there, you can look now. It's right above the actual sine key. It looks like sine to the -1 exponent, but it really stands for just inverse of sine. We use it to find angle measures. So instead of being given the angle measure, we're going to use it to find the angle measure. Okay? Obviously, another example, or the example we can do for that one, is the one we just did. If we're given the sine of angle A is 0.8, then we can find the measure of angle A by taking the inverse sine of 0.8. Okay, so the order of operations, we'll practice this tomorrow in class on your calculator, is to take the inverse sine of 0.8. I'm doing it now on my calculator. I hit enter and I get approximately 53 degrees. Measure of angle A is 53 degrees. Okay? Now obviously you can have inverse cosine, inverse tangent. Okay, so you should be able to find all three of these buttons, if you will, on your calculator. You will get to that function by hitting the second or inverse key on your calculator and then hitting the original function. Okay? And that's how I got the answer over here of 53 degrees. So let's try some of these. They're asking you to figure out if the sine of A is 1/2, which angle is A? Which angle has an opposite side of 1 and a hypotenuse of 2? Because we know from SOHCAHTOA that if it's involving sine, it has to be opposite over hypotenuse. So let's look at the angles here. If we pick angle 1, the sine is the opposite, 5.2, over the hypotenuse of 6, and that is not equal to 1/2. But if we do angle 2 over here, the opposite is 3. Putting that over the hypotenuse gives us the 1/2, so obviously angle A is angle 2. Okay? Now, for the next one, this one is asking us to identify A based off a cosine. Cosine is adjacent over hypotenuse of 13/15. So the first thing we're going to do is we're going to find the cosine of angle 1. Still have my angle 1 marked. Cosine involves adjacent, so it's 3 over the hypotenuse of 6. So the cosine of angle 1 is 1/2. So obviously angle 1, this is not 1/2, is not angle A. The cosine of angle 2 is equal to adjacent, which is 5.2, over the hypotenuse of 6. Now, we're going to have to take our calculator and simplify these. 5.2 divided by 6 gives me a fraction of 0.867. And 13/15 gives me a fraction of 0.867. So that tells me that those are the same. And you can tell in this example then that angle A in this one for number 2 must be angle 2. Okay, you try the other two. Remember, you're comparing this fraction to what the opposite over adjacent is for both angle 1 and angle 2. That's for tangent. In number 3, you're comparing 0.5 or 1/2 for cosine to something that's adjacent over hypotenuse. See if you can figure out whether it's angle 1 or angle 2. That's how you answer these questions. Finish those on your own. Okay, this next part is going to involve the notation that we put in the chart above. So if I'm finding the angle whose sine, or whose inverse sine is 0.8, then we're going to use measure angle equals inverse sine of 0.8. We're going to type 0.8 on our calculator and hit second sine. For me, the order of this is actually second sine, then 0.8, but on your calculator you might have to hit the 0.8 first. When you do that, you should get 53 degrees. So my angle is approximately 53 degrees. Now, it says to the nearest degree. Remember, we're practicing reading our directions, so it was 53.13 on my calculator, so that gives me an angle of 53 degrees. For number 6, I'm going to write measure angle equals inverse cosine of 0.19. I'm going to type in inverse cosine of 0.19, second cosine 0.19, close parenthesis, and I get approximately 79 degrees. I'm rounding for all of these, so I'm going to use the approximation symbol. I want you to try 7 and 8 on your own. Remember, on your calculator, you're hitting the second button or the inverse button. It should be in the top left corner of your calculator. Then the tangent button. After you do that, you're calling up the inverse tangent. Then you type in 3.4, and you should get your angle measure. And I want you to do the same for number 8. Okay, this is kind of review. It says solve a triangle, and it gives you what it means. To solve a triangle means to find the measures of all the angles and sides. Okay? So we're going to use trig, just like we did in section 2, to find the missing side. And this time you can pick whichever one you want to call x, because we're going to find them all. So the first thing it tells me to do is find, in step 1, the missing side lengths. Let's go ahead and call JLX. Again, I don't care which one you start with. I'm just starting with JL, so I'm going to put an X there. For this reference angle, because I'm looking for the opposite, and the hypotenuse is what's given to me, I can tell right away, based off SOHCAHTOA, if you want to write that at the top of your page, that I am going to use sine. I'm given the hypotenuse, and I need the opposite. So what happens next is I write down sine of the angle. In this case, it's In this case, it's 38 degrees. Remember, we recognize that we're using O and H, so we're going to use sine. So I write sine of 38 degrees equals opposite x over hypotenuse 22. Putting this over 1 should look familiar to you. I'm going to cross multiply, and I get x, or JL, which is what I'm finding right now, is equal to approximately 13.54, and since we usually keep it to the nearest hundredth, we're going to do that in this case also. My units are millimeters. Now, what about the other side? The other side of the triangle, let's call it y, is also unknown, and you have a couple choices right now. You could use cosine, since it's adjacent to the angle, or you can use Pythagorean theorem now that we know that x is 13.54. So I could fill in 13.54, I could have the hypotenuse, I could do it either way. Okay? Now, the last thing is to find the missing angle measures, and since this is 38 degrees, then angle J has to be complementary to angle K. So we're going to say the measure of angle J equals 90 minus 38 degrees, or 52 degrees is the answer to that. Okay.